So in this video I will show you how to set up this. We'll start by making a static effect. Then we'll add a global bend effect. And finally we'll use the VertexColor to create this variation per strand. So let's go. Alright, so it's kind of here we left off some static foliage from an atlas, and this is what the final result would look like, but I will just unplug that. Okay, so we'll start here. I just have a super simple material where I plugged in all the atlas maps. I'll start by just dragging out and creating a reroute node here. Press C to make a comment, and I will just write WPO sway. I usually drive these effects with the sine curve because it's quite fast, and to drive that we use time. So right click and create the time node, and then drag out from that and write sine, and pretty much here we could just see if we get like a small effect here, and it will go from the output of the sine is -1 to 1, and this will go on all three axes here. So we'll start by creating a make float 3 and just input it to the x vector so you can see here, or the x component. So it's moving back and forth here, not looking super good, but it's a start. So that's the basis. To control the speed, we can just add a multiplier after the time. And the reason I want to do this kind of from scratch is you can make a million different effects based on kind of the ideas or concepts here. So hold down 1 and click to get the scalar parameter or float, and convert the parameter, and I would call it sway speed. So now I can control the speed of the effect. I think I'll start with 0.5. And so the first and most obvious thing is that they should be planted in the ground, so the kind of 0 C coordinate should not move. So how I do that is I get the node, or like a constant called actor or object pivot, and I get the subtract the world position, or the other way around really. So I get the world position of the point, I subtract the object pivot, and that will give me a kind of local coordinate. So I break that into 3 components, and I get the C component, which is B here, because kind of up and down, or the up value, and I will divide that by a max height, so the height of the effect. So same as before, holding down 1 on the keyboard, clicking will get me this scalar float parameter. They call it scalars in shader, I don't know why, but it's a float. So 100 is a meter, so that will be fine. Divide by that. I'll also promote it, convert the parameter, and call it max height, or sway max height. And I will clamp that between 0 and 1 to get the kind of fading out of the effect. It'll be max up here and 0 up here, but it will never go before larger than 1. And then I will simply scale this value by multiplying it. Plug in this guy in and hooking up to X. So what happened now is the bottom part is planted, and the top part is actually moving a little bit. So let's put in a amplitude as well. Multiply again. Hold down 1 in the keyboard and click. Convert the parameter. Sway amplitude. 30. Just to get a really clear effect. So this is all good, and but still it looks kind of really like mechanical, just a straight line. So I want to bend it, and I've done this with sine function 2 before, but I found this rotate rotate about world axis cheap, so I tried that and it works nice. It's a bit random, not random, but it's a bit weird. I had success using the x-axis output, and one could implement a rotation around C to get the direction from it, but for now we'll just use the x-axis rotate, and to get that done we'll do a rotation. This will be the rotation amount, and that is in this one, as it says here, is 360. So to get angles I will divide my value by 360 and input into rotation amount. And for now the pivot point will be the same as here, the object pivot, and the world position will be the world position of the point, like that. And we'll, okay, so we don't need this guy anymore. Apply. And as you can see now we have a large like bend from side to side. I will replace, next step I will replace the multiply with the value remap, because usually you don't want it to like bend all the way from side to side. So let's do a remap instead. So instead of this amplitude I will do min angle or sway min angle, copy paste max angle, take away the multiply, and I will do a value remap. Hold on one, click. So the output of the sign is -1, so this will be -1 to 1, and this will be, let's start with 10 to 20. So now it's like only rotating between 10 and 20 degrees, and this one moved up a bit. See if I can fix that. Okay, so I managed to fix it. What I did was I had to first I remapped the C coordinate here of the points, because apparently some points were you know, a bit over the 0 coordinate, and so they were rotated. And also I had to move the remap of the sign from -1 to 1 to this range before I multiplied with this kind of height fade. So okay, so this is where we're at now. Time multiplied by the speed parameter goes into the sign. Sign will output 0 to 1 range value, which we will remap to the desired angles that we want the bend to vary between. And then we will do the height fade, in which we'll take the absolute world position, subtract the pivot point of the object to get the local coordinate. If it's placed on a hill, I mean, you need to have the relative coordinate, not the absolute world. Get the C, the height coordinate, it's called B here, but it's always like vector is XYZ or RGB, it doesn't matter. Divide that by the max height, so you will get the 0 to 1 value over the height here. And then I remap that to get to kind of cut the effect a bit higher at 5 centimeters, so 0.05 here, because I had some of these bottom vertices that were rotated. So remapped again 0.05 to 1 to 0 to 1. And I clamped that to 0 to 1 to get rid of the high values, and then multiplied that to get the, so here you have the straight line, all the vertices are rotated, and here we multiply with this this height fade. So you can always right click and preview nodes. So if you multiply that with the bend effect or with the rotation effect, you will get this bend like this. Divided by 360 because this one is 0 to 1. Input of a pivot as the world coordinate or the pivot point, and the world position goes into world position. Then that goes straight into the world position here. Alright, so the next step to get the variation between the strays within the instance, you have to go to another app. Like what I did was I assigned a different value in the alpha channel of the VertexColor to these guys. So I did that in Houdini. I mean, you could paint it manually or like spray color on it. In the previous video we set up this. Strands within the instance, and then placing them on the origin and creating a bunch of points here and scattering the strands onto the points, and this is the final result. So this is the kind of foliage instance that we're going to use. So let's make some bigger points, point size, and also I'll get the dark background. And for this I will use a point swap. You could use an attribute randomize, so let's do that now because it's a lot simpler. So attribute randomize, you can do color. If you do, I think one dimension would be black and white. Yeah, so you can see we have some variation here. Seed, and you can also kind of look at it over here. I mean, it's hard to visualize, so just assigning some different values. I use the alpha. You could use the, if you don't use the other color channels, you can use any channel, but I will use the color channels for some other data, or I might do that. But for now, I just want to make a random float value between 0 and 1 in the alpha channel. So in Houdini it's called alpha, like that, and it's a float attribute. Okay, so export that, and back in here. So if we go here, double clicking gives you a reroute, so it can be quite nice if you want to organize your wires. So if I do an unlit material here, just to show it, and we go the emissive colors, we'll go VertexColor, and I will take the alpha and plug it in there, and we can also like unplug opacity here. So as you can see here, we have some different shades of gray on the strands, and that's the point. You just want like a per strand value that is different from its neighbor. So plug back opacity and make this two-sided foliage again. All right. So now we're back. It's all bending in the same fashion. So what we want to do is we want to go and offset the face, so the value that goes into the sign, to get it. I mean, the sign curve looks like a oscillating curve like this, and so we want to vary where on the curve we are. So I'll do this after the sway speed, and to get an offset I'll just do add, and what I want to add is the alpha of the VertexColor. So get the VertexColor, get the alpha, and to control the effect I will multiply it, hold down 1, convert to parameter, and we'll call it phase offset from alpha. Plug it in. So already now we have a quite cool variation here. Okay, so one thing to consider is that the face, or kind of the face size of the sign, you can set here. So if you want an angle sign, you can type 360 here, but the kind of legacy size of the sign is 1. So the face is 1, like 1 equals 360 degrees. So then the face size here will be quite effective already at default value. The kind of smaller face offset will just make it with like a little delay on it. Larger values will put them completely out of phase. So this is matter of taste here, or kind of what effect you want. Yeah, so I want something like this. Alright, so let's try it out. I think it looks good. You could always get your material instance up and change the settings. So that's a low face offset from color or from alpha. Some more variation. I mean, super large values will not kind of make more variations. There's a limit to the amount of variation, but it's always within the face, so to speak. All right, so this is the final result, and I think it looks quite good. So have fun with this, and see you next time. Ciao.